Good day, students. Today we are going to coin our attention to functions, and if historical opinions were to be divided, one will say it's one section that carries the highest marks in mathematics paper 1. So in the broadest sense, functions should be the center of your attention, and before I apply any leap of logic to the questions, please make sure you subscribe to the channel if you haven't done that for more mathematics content in a Mzansi context. Now, let's check. Question 4. We have the functions. By the way, we have the paper from November 2016. It's a national paper, so it was primarily functions. Question 4, 5, and 6, just right here. Let's check. Sketched below, which is question 4. I'm now going to do question 4. I'm just going to tick that. Sketched below is the function of h of x, which is equals to the base a to the exponent x, where a is positive, that means it's bigger than 0 just here. R is the y-intercept of h. The points P and Q lie on h. So the point P are that, and then the point P and Q are given as such. Now they ask you to find a few things. Let's check. 4.1, they say to you, write down the equations of the asymptote of h. And they give that stuff 1 mark. So I'm going to say to myself, let me start this situation here in a new page. And that is question 4. So I'm going to write question 4. And then we have 4.1. We want to write the asymptotes of this function here. That is h of x is equals to a to the power x. I want you guys to say something. They are giving it 1 mark. That means it's the basic stuff. When we talk about the asymptotes, we are given h of x is equals to a to the power x. Notice that this is the parent function of exponential graph, which behaves something like that. You know, if you guys remember your functions from grade 11. So these functions really, it has your y-intercept at positive 1, just right here. This is 1 of all the parent graph, and does not have the x-intercept, but it does have the asymptote at y equals to 0. I hope that you know of any base, you can take any parent function of a base, any base in fact, to the exponent x, like y equals to 2 to the power x. It can be 3, it can be 4. It has the asymptotes of this one. But say maybe they give you h of x is equals to 2 to the power x plus a q. So this q is the one which we are saying is the asymptote. But this time around, it's plus 0q. So this graph is basically defined above the line y equals to 0. So that is your asymptotes. So you're going to say, well, let me erase this stuff. So you're going to say to yourself that the first question is going to be y equals to 0 there. This is the equation of the asymptotes. I guess it's the takeaway for most of you guys. So it's really 1 mark. You don't need to stress about that one. I'm going to go to the next question. Let's check what are they looking for. They say write down the coordinates of R. So because we're still talking about the parent function, so the coordinates there, it's 0 and 1. Like I said to you, that any parent graph, as long as it takes this fashion, and even if you had its reflection, like y equals to a to the power negative x across the x-axis, it will still behave like that, the blue one. But the y-intercepts is really going to be 0 and 1. So I'm going to say, well, this is going to be 0 and 1. This is your point. It's 0 and 1. It's the y-intercept, the coordinate of R primarily. So let me just write that. That is the coordinates of R. And then we go to the next question. That should really be easy. They're giving you 1 mark so far. They want you to accumulate the marks here. Now they say to calculate the value of A. So now we want to find the value of A. So if I knew the point Q, I was going to use that. But because I know the point P, I'm going to substitute the point P in H because the point P passes through H. So what I will do, I'm going to substitute that point to H. So I'm going to say at point P, which is 2, 9. So this point passes through H. I'm going to plug it in the graph of H to get the value of A. So you have your H of X is equals to A to the power X. But remember that this H is the same as Y. The same as saying Y equals to A to the power X. But this point has X and Y. So I'm going to substitute those points. For those that don't know, this is X and then this is Y. Please don't make that mistake of interchanging unless if you are in the inverse situation. So you're going to get a 9 is equals to A to the power 2 for X. All right, so you're going to really square both sides, or you can really transpose 9 and solve by factorization. But this is really clear. It's 2 marks, I guess. Let me check the marks. It's really 2 marks, so you don't need to sweat here. So you just need to say, well, this is going to be plus or minus positive 3. But you are told that the value of A is positive here. A is what? It's positive. It's a primary guide, by the way. It's the guiding principle. So you need to tell them that the value of A is equals to positive 3 only. Now, you can do that. Please make sure that you specify that if conditions are provided on your table. So you can just say that this is where A is bigger than 0. That was told to you, but you don't have to really show them this situation. I'm just doing this for the purpose of understanding what I'm doing. Now let's check 4.3. 4.3. Let's go to the question and really get the analogy around that. They're saying D, it's a point such that DQ, such that this DQ here is parallel to the y-axis. So this is parallel to the y-axis, and DP, this one here, is parallel to the x-axis, and that is very clear that it's parallel to that. But let me really emphasize the issue of parallel and x-axis. How do they connect in functions? Now look, they are saying DQ, this one here, it's parallel to the y-axis. That means x remains constant in there. It means the x value at D is still B. Now they are saying that DP is parallel to the x-axis. That means y remain constant throughout. You know, it remains constant, that y. It means even the point here, y is still 9. Even at the point there, y is still 9. But for the x situation, it means this point here, x is still b, and then here, x is still b. This is the meaning of parallel to the y-axis, or rather to the x-axis. I'm just going to now emphasize that it means that the point D, is going to be B, and what? And 9 is the meaning of this statement, basically. Now, they say to calculate the length of DP. So they want me to write the length of DP. You can see that it's a horizontal length. This is a horizontal length. They wanted to find the length DP. So the horizontal length is basically the x right minus your x left, but the vertical length is primarily your y top minus y bottom. I guess that logic is also well mastered. So I'm going to find the coordinates of D, But before I do that, they want me to find the length of DP. So check, DP is the horizontal length. That is equals to the x at P, this P here, minus the x at D here. If you can be able to really get that correctly, this one is the horizontal length. Let me write it here. This one is the horizontal length. We also have the vertical length. I think I need to give it to you for 3 years. But for vertical lengths, that's when you say it's y top minus y bottom. And that's where you also do your maximum length and your minimum length, because it largely results in a quadratic space. So I want to find the x at what? At D, because the x at P I know is 2. But the x at D, I don't know it. I just know that it's B. And so what I can do here is to get the value of B through this equation, because this point lies on the graph of H. So it's going to be very easy for me to find the point, the value of B, if I have the y value of that. Plus now I have the value of A, so I can really do that. So I'm going to say to myself, this is y equals to 3 for A to the power x. But I'm going to say at a point Q. So I'm going to say at point Q. So what is Q? Q is B, comma 81. This should be 81 here. So I'm going to plug this point and really get my y value. And that is going to be y it's 1 over 81 is equals to 3 to the power B. And then I can really write that to say that that is equivalent to, if you know your exponents very well, you will say this is really going to be 3 to the power negative 4. It's really easy. But if you are battling with that, you can say first is 1 to the power negative 2. Is equals to 3 to the power B. These are necessary steps, by the way. But if you don't trust your capacity, you must do it. So I trust mine, but for the benefit of your attention, I'm doing it. This is going to be 3 to the power 2 to the power negative 2, which is equals to B. 3 to the power B. So you need to really solve for B. Remember that. You need to solve for B. So I'm going to say to myself, okay, in fact, let me just continue, but let me just do it here. So this is going to be 3 to the power negative 4 is equals to 3 to the power B. Because now the bases are the same, I think you have learned that principle, that if the bases are the same, you can now drop their exponents, and that will then give you B is equals to negative 4. That means the point B, it's negative 4. So let me reduce this situation here. Let me reduce it. So it means now the point P is what? This was 2 and 9, and then the point D. Oh, the point D is what? You now have your B. So your B is minus 4 and comma 9. Remember that. So this one is the horizontal length. You then now say to yourself, therefore, the length for DP, like I said to you, this is equals to XP minus XD. Is the horizontal length. You must study the length of functions. So now you're going to get the length at P, that is 2, minus the length at D, that is a negative 4. And as a result, you're going to get a positive 6. I won't really do that. You punch it in your equation to get, because this one is a length, students. You must not forget to write units. This is 6 units. It's the length of DP. If you have any question on how I'm doing it, please don't forget to comment so that I can explain on the comment section. Well, this is how you go about 4.3. I'm gonna look at 4. No, this was 4.4 primarily. So I was doing 4.4. Okay, this means this was 4.3 here. This is 4.3. My numbering was bad. So this should be 4.4. Now we are going to 4.5, seemingly is the last question. 4.5. They say determine the value of k for which the equation, that is h of x plus 2 plus k is equals to 0, will have a root that is less than -6. Okay. So we are given the equation. I want you to be very careful. We are given the equation that is x plus 2 plus k, that is really equals to 0. Please, guys, listen to me carefully, because this is where the water doesn't hold in the exam room. I think for those of you who are getting what I'm saying would really catch the flow. But I want to give you the wider view of how to approach such questions. Remember, they're saying for which values of k will this equation have a root that is less than -6. I want you to listen to me very carefully. Listen. What is h of x? So h of x, you know it to be 3 to the power x. Now we want to translate it. We want to translate it. H of x plus 2. If I translate it, this means I'm going to have 3 to the power x plus 2. I'm translating horizontally to the left, you know, and I'm going to put a plus. No. This one is it's h of x plus 2. Why am I doing this? Maybe the premise of your concern should be, why am I doing this? Let me answer you. We are given this particular situation that we must really play with. So this means that whenever I see this, I can replace with this one. And that is 3 to the power x plus 2, and then plus k is equals to 0. But this is a function. Check. This means that you're going to have a 3 to the power x plus 2 is equals to -k. Think about it. And more often than not, we have that function, that one as a function, equaling to y. This is basically your y now. This is now your y. So we are saying, if you translate h, which is this one, horizontally to the left, to the right, let me check, to the left by 2 units, what value of k would that situation be? Have a value of a root of less than -6. Let me put it in practical. Let me delete even this one here so that you see something here. Check. You have this one, which was the original function. This particular function just right here. This is the one that you are given. You want to translate this function to the left by 2 units. Check what I will do. I'm going to move 2 units. I'm going to move 2 units to the left. That means I need to move 2 units to the left for x, remember that. And then it means I'm going to have my y-intercepts at that point, which is going to be at 9 to the left. But remember, you obtain your b here to be -4. It means here is -4. You want to move -4 to the left by 2 units. So you're going to have a -6 if you move to the left by 2 units. You are moving with that point, by the way, of Q. Now check. I'm now going to translate this function just like that. We're just going to cut at 9. I'm now moving to the left, and then let me make this one blue so that you see what is really happening. So I moved to the left by 2 units. The center for discussion, the center for this question, in fact, should be in this question. Check. You will see that if you move that Q, Y is unchanged. Y is unchanged, by the way. You are moving this Q to the left by 2 units. It means you are now sitting at -6 and 1/81. I don't know why I write 18. So that means you're going to have -6 for x and 1/81. We are saying, read the question. For which values of k will the equation, this equation which you managed to play, will have a root that is less than -6? Less than -6, we're talking about this region. This region is the one that is less than -6. So in this region, you will see that the value of y here, remember that that -k, it's primarily your y now. So you will see that your y, which is -k in this case, it's going to be less than, it's really going to be your less than that y value there, which is going to be 1/81, but it's going to be bigger than, because you can see it's really approaching 0 as it's your asymptote for this equation. So it's bigger than, it's going to approach 0. Let me just write it here. Bigger than 0. It's going to approach 0, but we'll never touch it because it's the asymptote. So y is less than this particular y value here. All right. But bigger than the y, the y as the asymptote, which is 0 in this case. So you are going to say to yourself, as per the question here, you are now going to say that, therefore, this is your y, which is -k. It's going to be less than 1/81, but it has to be bigger than, bigger than 0. Your y is now replaced by -k. So you just need to divide throughout by a negative and get your value of k. And that should really suffice to k. It's going to be bigger than, if we divide by negative, inequality changes. That becomes -1/81, but less than 0. So this is your solution to that particular problem. That should really be easy, you know. And then this is how you really go about this one. This is how you should really do that. Well, let's check the next question. Like I said, if you have any question, please comment. I'll be reading your comments. So we are going to spend some amount of time here. Let's go to question 5 and really check how you will approach that question of question 5. It's really easy, I don't want to lie. So here they are really giving you parabola and your hyperbola, and I think by now you guys should be knowing what is happening about parabola and hyperbola. It's just that you need to have questions. They are saying sketched below is the parabola f. So f is parabola. You can somehow sketch that situation. So that is your f with the equation. So they even give you equation. That means like it's really easy. And hyperbola g with the equation. So g is given by x minus p into y plus t is equals to 3. Well, they say b is the turning point of f. The turning point of f lies at the point of intersection of the asymptote of g. And a is the x-intercept of g. Okay. Now they say show that the coordinates of b that one. So what is B? Then let us check the locativity of B. What is B? B is it's the maximum turning point. This is the maximum turning point. Remember that when you have A as negative, this graph is going to have a maximum, and if A is positive, it's going to have your global minimum in there. So we are looking for the turning point. Again, that should be very easy. We're given f as negative x squared plus 4x minus 3. That should really be easy. Let's do it together. Question 5. Let's try that. Question 5. Let's check that. Question 5. We are given f at x. So let me write 5.1. We are given f at x that is equals to negative x squared plus 4x minus 3. You want to get the turning point here. That should be very easy. There are two ways to really find the turning points. The other one, because this is it's a quadratic function from grade 11. You can still use your grade 11 techniques to say the turning point occurs at x is equals to negative b over 2a, where you have a, b, c there. So you just need to say, well, that is a negative 4 divided by 2 into a. So your a is primarily negative 1. And as a result, you're going to get, I guess this is going to be negative 4 over negative 2. And that should really suffice to positive 2. Really easy. That is really easy. It's a straightforward situation. So this is the x value of the turning point. You need to get the corresponding y value. That should be very easy. You say to yourself, well, y of the turning point is going to be f at 2. And that is going to be equals to negative of 2 squared plus 4, 2 minus 3. You need to type it to get that value. So this is going to be negative 4 plus 8. It's positive 4 minus 3, so it's 1. Yeah? So it means that the coordinates of B is going to be x is 2, and the y value we just found that to be 1 is this particular one. That is really easy, and I want you guys to pay attention. So, but because you are in grade 12, you know that the turning point, this is the first method to do that. The second one will be the turning point occurs at the first derivative being equals to 0, and then you solve for x. That means you're going to differentiate. Let me do this quickly. That means you're going to differentiate this function, and that is going to be f prime at x. It must be equals to 0. You know, that's where the turning point occurs. It's called a stationary point. So this is going to be negative 2x, and then a plus 4 is equals to 0. And when you solve for x, you're going to get x is equals to positive 2. And the same stuff, you plug it here, you still get 1. I'm just trying to give you the baseline scenario on how you're going to approach this one. This one is still applicable because you are still fresh from grade 11. You still know it, so use it. You would get 3 marks for that. That should really be very easy, or you can do your completing of the square and you know those things. Well, let's get 5.2. How many marks was that? That should be 1 mark or 2 marks. It's 2 marks. So they're giving you 2 marks here. Now they say write down the range of f. Well, when we talk about the range, I think I need to emphasize this to students. When we talk about the range, we are talking about it's a set of y values for which the polynomial, or rather any graph, is defined. This graph is not defined above y equals to 1. It's defined less than, below 1. is defined just right here. We're talking about the f, remember that. So this should be very easy to you guys. This should be very, 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 very easy. Let's check. You want to write that range. Well, there are many ways to represent that. Your range is basically your y value of the turning point. It's the maximum y value. But check if if the coefficient of a is negative, you are going to have a y less than. But this has to be inclusive, because the graph of quadratic, they are defined everywhere. They are not like hyperbola and your exponentials. These ones, they are defined everywhere. So you're going to include that on the basis that f at 2 is defined. So you're going to say, well, you're going to, if the coefficient of a is negative, you're going to have this inequality, or you can interpret the graph. You'll have y less than the y value. But if you're having a minimum y value, that means you're going to be having this shape just right here. Let's say maybe you had b as 2 and 1 here. It means your range was going to be y bigger or equals to the same y value, because a was going to be positive. A was going to be positive. Remember, even the shape, it says that a is positive. So I hope you know how to get the range, or you can really interpret the graph. I advise students to also interpret, because that's where they really trick you there on the issue of interpretation. So this is how you're going to write that. The other acceptable way of writing it is to say that let me give you the other way of doing it, because some schools have their representation. So you can say y is the element of real numbers from negative infinity to positive 1 inclusive. You are basically writing your inequality in the interval notation. I guess that should suffice to how we should approach this particular one. This is really easy. I don't want to try students. Now you get to 5.3. Let's get 5.3. What are they looking for there? Let's go and read. They are saying, for which values of x will g be bigger or equals to 0? Okay, check. You at b, so many things happening. It's the intersection of what? Of the asymptotes of g. Remember, this is your g here. This is your g. Okay, so that is the graph of g. And then you also have this one approaching the very same asymptotes. Okay, let me just cancel that. And then you have that. I wanted to say something. This is the y-intercept of g, and that is -1. So this is -1. And then here you have 2 here. And then you also have y equals to 1. That means at that point it's 1. So they are saying, for which values of x will g of x be above the x-axis? Where is g above the x-axis? Well, let's look at this branch first. Where is this branch bigger than 0? Above the x-axis. When they say bigger or equals to 0, they are basically saying to you above the x-axis. Look above the x-axis. Look above x-axis. So we're talking about this region here. You look at this region, just this region here. So that's where this graph is above the x-axis, because look at it in this way. Here is below the x-axis. So you just need to interpret that from here, oh my goodness, From here, it's x less than -1, but inclusive because it's defined at -1. It's the intercept. So you're going to say it's x less than or equals to -1. You also look at this branch. This branch, if you look at it nicely, it's above the x-axis. But we are not going to touch, remember that x here is 2. So from here to this side, it's x bigger than 2. But we can't include 2 because it's the asymptote of g, and we don't touch the asymptote. So x is going to be less than or equal to -1, or x is going to be bigger than x is 2 just here. It's above the axis in this particular region. Let me just delete this one. In this region, this branch is above the x-axis, but it's from when x is equals to 2 upwards. All right. So if you interpret that, you say that your x is less than or equals to -1, or x is going to be bigger than +2. This is how you're going to interpret that one. You look at where is x above the x-axis. But if they say less than 0, you look at below the x-axis. All right. This is very easy. I guess you get that sense. They now say determine the equation of the vertical asymptotes of the graph of h if h of x is equals to g of x plus 4. They want the equation of the vertical asymptotes. So now you're going to think about it in this way, that you have 5.4. You are given h of x is equals to now g of what? Of x plus 4. Think about it in this way. You need to understand what is happening on g first. So we are translating g horizontally 4 units to the left. Think about it in this way, basically. Like if you have a g at x, what is g at x? In fact, get the vertical asymptote of g. If you look at the graph, the vertical asymptote of the graph of g, it's basically that 2 there. That's where the vertical asymptote occurs at g. But you want to shift that asymptote, to the left by 4 units. So let's write first the asymptotes of g. So that is going to be x is equals to 2. This is going to be 2. This is the vertical asymptote of g. So now for the vertical asymptote of x plus 4 of this one, which is equals to h, you are going to then now say, well, this is going to be equals to, you translate it horizontally by 4 units to the left. That means you're going to have the original one minus 4, and that gives you a -2. You are going to translate the original one to the left by 4 units, which means negative. If it was to the right, it was going to be plus. So therefore, the graph of h of x, they have the same vertical asymptotes. They have the same vertical asymptote, which is -2. All right, as per the equation. So therefore you are going to get x is equals to -2. This is the vertical asymptotes of the equation of the graph of h if h is given by g of x plus 4. Yeah, I think that should suffice for 5.4. Extremely easy. Let's check if we have 5.5. Let's check that if we have 5.5. 5.5, what are they saying? Determine the values of P and T. The values of P and T. Here are your guys, P and T. Okay. So you're given that is the equation of G, by the way. Okay, so that is x minus P into y plus T is equals to 3. Okay, that should be very easy. Check. You are given x minus P into y plus T is equals to 3. This is the equation of G. This is the equation of G of x. It is given as that you need to get the values of P and T. So how do you do that? I'm going to apply algebra. Remember, you are used to y equals to a divided by x plus or minus P, and then a plus your Q there. You are used to this standard format for this type of graph called hyperbolic. What you're going to do here is to make y the subject of the formula. That means you need to divide throughout by x minus P, throughout by x minus P. So this will then undo each other with those two terms. So you're going to have y plus T is equals to 3 divided by x minus P, like that. So if you make your y the subject of the formula, you're going to get y equals to 3 divided by x minus P, and then a minus T. But this situation is given at the point just right here. Everything is given. The point B, they basically give you the values of T and P, but this is 4 marks, so it's unbecoming. That means you just have to really play with algebra there to say P. I mean, the point B, it's primarily the values of P and T, but you must determine. Not they. Please check that they didn't say write down. They said determine. So you have to really solve them. So, but you can see that if you are to solve for T, let me say that point B, let me go down there to say that at point B, which is 2 and 1, at point B is the intersection. It's the intersection of what? Of the asymptotes. Of the asymptotes of G. The point B is the intersection of what? Of the asymptotes of G. What are your asymptotes? We are talking about these ones. These ones are your asymptotes. And then even that T there, that is your asymptotes. All right. So to find your T, you are going to then say that this situation, that is a negative T, is equals to the Y value here in the asymptotes, and that is 1. So therefore, your T is going to be equals to negative 1. All right. But for P, remember that you have it in this way. So in order for you to have the correct view on that, you can do the same way, but be very careful that your P is going to be primarily. Let's check also the graph, the way it's given to you, the sketch. You have it in the positive direction scale. So that means your P there, it's going to be positive 2. So your P is going to be positive 2. All right. I will tell you why. So your P is going to be positive 2 on the basis that if you replace these ones, if you replace the function back, check. If you replace them back, like 3 divided by your x minus p, which is 2, and then minus 1. This should be in agreement with what you are doing and what is happening. Check. If I say determine the vertical asymptote of this one, you are going to say that x minus 2 is equals to 0. Therefore, x is equals to positive 2, which is your p in the graph. So you must also observe the diagram as well to get the gist of what is happening in there. Now you look at your last question, 5.6. They say write down the values of x for which for which f of x multiplied by the g prime of x is going to be positive. So allow me to really erase some of these things here, unless if I will need them. In fact, let me delay them so that I am able to interpret, because these questions is basically interpretation, but it's 4 marks. Okay, f prime times, f at x times g prime at x is going to be bigger than 0. Okay, that is 5.6. So this is 5.6. I wanted to be very careful. I'm looking for the values of x for which this occurrence of f at x multiplied by the g prime at x is going to be big or equals to 0. So we are looking for the region where when you multiply the two graphs, they really give you a positive situation. There are two cases here. It's either when you multiply positive and then with a positive. If you multiply positive with a positive, you're going to get a positive situation. Or if you multiply, or if you multiply negative, I'm just saying negative, times a negative, I don't know, I'm writing 1. If you multiply negative situations, this is going to be a positive as well. Positive, I mean to say. So you're going to have these scenarios in your graph, but I wanted to look at it in this way. We are looking for the values of x, but we are using the y values to interpret that, or rather to multiply what we are looking for. So that for me to really have this correctly in the best of my mind, I will need the intercepts. I will need all the x-axis, the x values in the intercept space. That means I need the value there and I need the value there, because I have this particular one here, and that is -1. So I need to get what is this one and what is this one, so that I can be able to read it properly. And if you look at this point, are the x-intercepts of the graph of f. So allow me to find the x-intercepts of the graph of f. Well, let me find the intercepts of f. So what was f? My f was given, my f at x was given by -x² and then a plus 4x and then a -3. I need to get the intercept of this one. This is really going to be -x² and then a plus 4x -3 is going to be 0. I want to find the intercepts. Please get that. So this is going to be really x² and then a -4x and then a plus +3 if you divide throughout by your -1 there. So you can do this by factorization, and that is going to be x, and then the factors are primarily going to be 3 and 1. They are all negative, I presume. So therefore, my x is going to be +3, or x is going to be equals to +1. They are all positive. So I'm going to look at my diagram where is 1 and 3. Well, my my diagram is drawn into scale. So I'm going to get a 1 here and then a positive 3 just right here. Remember here it's positive 2. So it really matches what is happening there. You also need that 2, but that 2 is primarily your, it's in between 1 and 3. So you may really throw it away. It is 2. We are going to check if really we need that. So this is negative 1 there. You have that scale. You need to really check it very carefully. We are looking for the values of x for which f, which is the y value, multiplied by this one. This one is the g prime. It's the g prime. Let's check how are we going to really get the g prime. We need to get the g prime. Let's get our g prime. Well, we get g at x is equals to 3 divided by, what was my g? So my g was x minus 3. And then a plus, was it minus or plus? Minus 1. Okay. So I need to differentiate, I need to get the g prime. G prime means derivative. So I need to derive this. I need to differentiate that. You can use your rules of derivatives, or you can use your first principle to derive this one. All right. So I'm going to use rules of derivatives to get the g prime here. Let me get the g prime at x. You need to be very careful, students. I warn you. If you derive negative 1, that is a constant. It's going to give you 0. But if you derive this one, you need to use rules of derivatives. So I'm going to jump a lot of steps here. You need to derive it. You're going to get a square that, and then a minus 3. I'm using the rules of derivatives. You can use first principle to check if you arrive to this location here. So that is going to be 0 minus 3 into 1. That is going to be that, and then a plus 0, that if I derive negative 1. So it means that my g prime, please use first principle if you are unable to use rules of derivative. So my g prime is x minus 3 to the power 2, and then I have negative 3 in the numerator. Now, this is how I will do a shortcut of this one. Check, my g prime will forever be negative. Check why. This situation here, it's a positive thing. This one, it's a positive number. If you divide that positive number with a negative number, what do you get? You get something which is going to be 0. Well, this should be 2 here. I don't know why I wrote 3 instead of 2. So let me erase that. That is going to be 2 here. And then let me put 2 here. This should be a 2. And then also here, this should be a 2. This should be a 2. But the bone of contention is basically here. If you take any value of x, you say whatever value of x, if you put it here, you are going to get a positive situation. But that situation, if you divide by negative 3, it's going to be a negative stuff. So that means the g prime at x is what? Is less than 0. For all real numbers, so x is going to be less than 0. That means if you take any value of x, but if you take 2, and put it here, you are going to face a serious crisis. So I therefore urge you to tell them that x cannot be equals to positive 2. That statement at least tell them that x cannot be equals to positive 2. But for any value of x, the g prime is always negative. That means now, if I'm looking for f prime, f at x multiplied by the g prime at x, such that this is going to give me a a positive situation, that means I already know that my g is going to be a negative. So I'm going to look at the graph of f where it's negative, because remember I said to you, you need either positive or negative. So my g is my guiding factor now, that this is negative. It means this has to be negative, this f. So now I'm going to say, well, let me check where is f less than 0. That means negative. I need to check where is f less than 0, because this is negative. If I multiply negative and the negative, I'm going to get a positive. Yeah. So I'm going to go to my graph and check where is f below the x-axis, which means negative. So if you observe carefully, you will see that this graph is negative, just right in this direction. This is where it's negative. This is where the graph is negative for x is less than or equals to 1. Remember, that is quadratic. So these ones are defined everywhere. And then or in this situation, this graph of mine is below the x-axis, which means negative. All right, which means negative. So this is how you're going to interpret this type of questions. So it means now you are going to then say that, let me check again, x is going to be less than or equals to 1, or x is going to be big or equals to 3. This is how you're going to really attack this question, to say, therefore, x is going to be less than or equals to 1, or x is going to be big or equals to positive 3. I guess you get the sense of that. That was the last question on this particular one, and then it was having 14 marks. Yeah, you had to fight for those 14 marks. Well, let's refresh with question 6. Let's refresh with question 6. Our last question. Well, it's a combination of a straight line and a log function, so you must switch your mind to a straight line and this stuff of your log. They are saying given f at x is equals to negative x plus 3 and g at x is equals to log of base 2 of x. They say on the same set of x's, sketch the graph of f and g. Clearly showing all the intercepts with the x-axis. Okay, so they give you f at x is equals to minus x plus 3, and the other one is the log of base 2. So it's the basic functions, basically. They wanted to sketch them on the same set of x-axis. So that is question 6. That is question 6. Let's check. You are given, they are saying given, they give you f at x, that is equals to minus x plus 3. They also give you g at x, that is a log of a base 2 of what? Of x. So they wanted to write, to sketch them on the same set of x-axis. So I'm going to, this is a straight line, so I'm not going to sweat that much. Let's get the x-intercept of this straight line. It's when y is 0. So this is when y is 0. I'll say, well, the points here are going, when y is 0, That means this situation is going to be 0. I solve for x. And then it's going to be, x is going to be positive 3. And then y is 0. And then the y-intercept, let's get that. Y-intercept, that's when x is going to be 0 there. If you put 0 here, you're going to get 3, right? So therefore, you're going to get 0, 3 as your y-intercept. But for this one, it's the parent graph for logs. That means you're only going to have the x-intercepts. You do not have the y-intercepts here. So the y-intercepts are going to be at is the parent one. That is primarily 1, 0. Is the inverse of the exponential one, primarily. So if they had to ask you inverse points, I mean the y-intercept of the original one, which is the exponential one primarily, it's 0 and 1. So you're going to sketch these ones. This should be very easy, students. Let's check. But you must do even the easy stuff, eh? In the exam, easy stuff becomes the difficult thing. So you're going to have this situation just right here. You get your y and you get your x there, x-axis. And then what do you need? You need 1 and 3. You need 1, 2, and 3. So this is 1, and then a 2, and then your 3. You also need y-intercepts there at 3. So this is going to be really 3. I'm going to start with a straight line. It's just going to behave like this. It's a straight line at those points. So you can show the arrows that it's a continuing function. It's continuous everywhere. You also need to graph this one. Like I said, it's a parent graph. So it's going to pass through 1. Then let me really have this color here. This is how the log graph behaves. So you're going to have that. Well, this is g, ne? This is your g at x, and then this one is your f at x. Well, they intersect somewhere there. You can see that they really intersect there. I'm not sure if they will ask the intersection, but you'll really solve that if you are able to solve it. So this is how you're going to sketch it and label them. So you can see that these are your points there with the x-axis, really shown clearly. You just need to go to the next question. How many marks was this thing? This was given 4 marks. So they were giving you guys marks here. They're now saying write down the equation of g to the exponent -1 of x, the inverse of g, in the form of y equals 2. So they want the inverse of g, which is going to be the exponential graphs. Remember that the exponential and the log graphs are the inverse of each other, and then the square root and the quadratic one are the inverse of each other as well. So this was question 6. No, this was 6.1. And then 6.2, they want the inverse of g. But remember that g was given by log of base 2 of x. I said to you that this g, it's primarily like a y. This is your y. It's the same as y log of base 2 of x. I hope that you know. So you just need to get the inverse. How do you get the inverse? You interchange the x and y. That means y becomes x, and x becomes y. So you're going to get the log of base 2 of y. So you need to apply properties of logarithms to say that this one here, which is y, is equals to the base of 2 to the exponent x, which is this one. So you're going to get 2 to the exponent x. So this is the inverse. Like I said, it's the exponential and the logs are the inverse of each other, and the square root and your quadratic are the inverse of each other as well. So this will then mean that you're going to get the g inverse being equals to your y equals to 2 to the x. This is how you're going to get 6.2, and that is 2 marks. It's really easy. I hope you can see that it's easy, and I'm making it easy, I believe. Well, let's check 6.3 here. 6.3. What are they saying there? I didn't really check the question. 6.3. They say explain how you will use 6.1, this one, and 6.2 in those questions to solve the log of base 2 of 3 minus x is equals to x. Explain how you will use the first 2 questions to solve the equation of log base 2 of 3 minus x is equals to x. Okay, let's have it down and we'll explain how we're going to solve it. So I don't really think solving it's a crisis. So we have log of base 2 of 3 minus x is equals to x. How are we going to make use of these 2 questions? Well, I'm going to apply what I explained just now to say this one here, that is 3 minus x, is going to equals to the base, which is this base, and that is 2 to the power that one, or to the exponent that one rather. So this is what you're going to get. How are you going to solve this one? But I want you to see something now, very, very tricky. This one is the same as negative x plus 3, and it's going to be equals to 2 to the power x. Check. If you'll agree with me that this particular function, it's f at x. So this is f at x. It was given, and you managed to sketch that in 6.1, hence they said 6.1. Now, if you observe this particular one here, is the one that you just found here. So how are you going to solve that? So that is the intersection of the g prime, the g inverse, not prime, the inverse of g and the f at x. So how are you going to really solve that? You're going to reflect the graph of g about the line y equals to x, which talks about the inverse situation. If you remember your inverse, you're going to see that that's where you reflect the graph about the line y equals to x. It's basically a symmetry line to obtain your g prime and determine the point of intersection for this one. And it's primarily going to be easy. So now I'm going to then say that you're going to reflect the graph we're explaining now. Reflect the graph of g about the line y equals to x to obtain or to really get your g inverse there, which is the inverse of g, and find the point of intersection, and find the point of intersection of f, because this is f, of f and what? And the g prime of that. Then just write the g prime like that. So this is how you're going to explain it. I don't know how many marks it was given, but that should really be very easy. That's the point of intersection of the g inverse and f. basically. So you could have explained it in your best way. Well, let's look at 6.4. I guess this is the last question. We've been here for live, guys. We've been here for so long. And write down the solutions to this equation. They wanted to write down the solution to this equation. Okay. Okay. They want to now to write down the solution to this particular problem. Okay. They wanted to write the solution of the log of base 2 of that was what, 3 minus x is equals to x. So we agreed that this is going to be resulting in x minus x plus 3 is equals to 2 to the power x. So what I will do is I'm going to find this graph. I'm going to draw it because this one I already drew it. So I just need to look at my sketch. I'm just going to draw the basic graph of that. So, well, forgive me if my sketch is not really proper. I'm just trying to make sense here with you. So let's check. This graph, they are intersecting here. So let's check. Let's check at that point. What is the rationale there for the x value? Where are they intersecting? They are intersecting at 1. I hope you guys can see that. They are intersecting at 1. This stuff here, this line, that's where they are intersecting. At that point, x is equals to 1. X is equals to 1 for this equation. So you're going to then say, but if you are smart enough, if you have the brain power, you can say, when x is 1, what do you get here? You get positive 2. And then how about here? When x is 1, you get positive 2. So these graphs are equal when x is equals to 1. That is the point of intersection. It means that x is equals to positive 1. This is how you would go about it, guys. And thank you very much for watching. If you have any question based on how I did these functions, please let me know in the comment section below. And it was nice to be with you today, guys. And still, guys, I'm wishing you all the best for your exam on the 4th of November 2022. And then up until next time on finance, I will discuss finance and probability next time. So please make sure you subscribe to the channel to get the latest update. Thank you very much.